Hi student, this is Sendil Selvi, Professor, Department of CSC, SRM Institute of Science and Technology, Ramapuram. Today I am going to discuss about fog computing. So, what is fog computing? Before going to discuss about fog computing, we should know about Internet of Things. What is Internet of Things? So, large number of heterogeneous physical object connected to the internet. Nowadays, everyone using the smart devices. That devices are connected to the internet. That is called Internet of Things. Things nothing but that is object. It include the animals, vehicles, farms, factories, everything. It is connected to the internet. So normally these internet connected devices normally follow the cloud-centered architecture. What is cloud-centered architecture? The smart devices generate plenty of data. Their data are stored in the cloud. So whenever we need a calculation, it will retrieve the data from the cloud and used for the calculation, it will provide an output. But normally, the cloud-centric IoT architecture faces some challenges. What are they? That is, we can simply call it as blurs. That is, bandwidth, latency, uninterrupted one, and resource constraint and security. We will see one by one. First, what is bandwidth? Normally, large amount of data produced by the objects in IoT will exceed the bandwidth availability. For example, consider our mobile as a smart device. So, in this device, we suppose we want to share some data to the some other device. It will need some bandwidth to send. But normally, our mobile device has a limited amount of bandwidth. Due to that limited amount of bandwidth, we are not able to send the data properly. So it limit the large amount of data. Next one is latency. Due to the limited bandwidth, we already discussed, that is we are having limited bandwidth in our smart devices. That's why there is a delay in the data transmission. Next one, we expect a uninterrupted data transmission between cloud and the front end devices, that is smart devices. Our unstable network connectivity make the long distance communications is a interrupted one. It means that if you are we are transmitting data from our IoT devices to the cloud and from cloud to the IoT devices makes the interrupted one due to the unstable network connectivity. Next, resource constraint. So what is resource constraint? Normally, small devices operated with battery power. So that battery power devices not support the end-to-end transmission via internet. It consumes lot of energy. That's why the battery quickly tried. Hence, resource constraint is one of the problem occurred in the cloud-centric IoT. Next one is security. So frequently, we have to update the software, security softwares available in the front-end devices. But the front-end devices may not have sufficient resources to protect themselves from the attacks. So the attackers may damage or control front-end devices and send false data to the cloud. So once again, I'll summarize. What are the drawbacks available in the cloud-centric IoT? First one is bandwidth. So large data produced by object in IoT will exceed the bandwidth availability. Our smart devices have limited amount of bandwidth only. Due to that limited amount of bandwidth, we face the problem of latency also. And our network connectivity is an unstable one. That's why we are meeting the problem of interrupted service. Actually, we need the uninterrupted service. Next one is resource constraint. All the devices are battery powered, so that battery power not support the end-to-end transmission in the internet. Next one is security. We can't able to update the security softwares available in the front end devices. These are the challenges in the cloud centric IoT. Next one, how it is rectified. This is the architecture for fog computing. This is fog computing architecture. So how we rectify these problems, these challenges by introducing fog computing, we rectify the challenge blur. See observe the diagram. See in this diagram, so we see the number one. In the number one, uh, see, it is an example for cloud computing, the smart device directly connected to the cloud data center. It is called cloud computing. Observe the number 2 application. The smart device connected with, it is a bi-directional connection. The smart device connected with the edge network. This is called edge network. That's why this is called edge computing. Observe the third, that is smart farming and smart factory, that is connected with the core network resources as well as the cloud data center. This is the third one connected with core network. It have a bidirectional communication. And fourth one connected with the core network as well as cloud data center. If necessary, it move to the cloud data center. Okay, so it is an example for fog computing. So cloud computing, smart devices directly connected to the cloud data center. Edge computing, smart devices connected with the edge network resources. And fog computing, the smart devices connected with either core network resources or cloud data center. So the cloud computing architectures problems were rectified using fog computing. It also include edge computing. Then in fog computing architecture, fog enabled IoT system and distribute the simple data classification task to the IoT devices itself. Then that is called, we see the example in a edge computing. No, this first one is, it's a example for edge computing, and assign the more complicated context reasoning task at the gateway devices. So this is example for edge computing. So further, for the analytics that involve terabytes of data which requires higher processing power, the system can further move the process to the resource to the core network. So such as the data centers of wide area network service providers, or it can utilize the cloud. So that is it reflect the application of uh, fourth one. Okay, so normally a simple task processed in the device itself. Suppose we are wearing a smart watch, we want to, all the smart watches having the capability to check blood pressure, then our walking, how much distance we walked, how much calories burned during the day. That is calculated, the device itself available in the local memory. So that is not communicate to the cloud data center every time. So this is example for edge computing. The everything happen in the edge devices itself. That is called edge computing. Why the name fog? Actually, in a normal cloud computing, it is very the distance place we are stored in the data. That's why from the real time example, it is far from here. That's why this is called cloud. Why it is fog computing? Under the cloud, fog is there. That's why it is called fog computing. There is nothing technical about the fog computing name. Next, fog edge computing, completing the cloud centric architecture. So what is the advantages of fog? FEC means fog edge computing. So far we discussed what is fog computing and what are the challenges in the fog computing. What is the architecture of fog computing? Now we discuss about the advantage of fog edge computing. So these concepts will arrive in the Internet of Things. That is the devices which are connected to the internet every seconds generate a plenty of data that will be stored in the cloud data center. If you are every time we are accessing the cloud data center, it will take long time. It has we already mentioned, we have the drawback of blur, that is bandwidth, latency. Then it is a interrupted service, and also it has the problem of resource constraint and security. Now what is how it the rectify the fog edge computing rectify the disadvantage of cloud centric architecture. Scale, we can shortly call it a scale: security, cognition, agility, latency, and efficiency. So how it provide the security, we will see, and how it provide the cognition. So in the fog edge computing make by provide security by updating the security software frequently via the wireless nodes. So FEC provide a software update in the front-end devices. Next one is the cognition. What is cognition? The ability of the devices at the network edge. It means that there is sensor at smart devices to process information locally, learn information, learn from the data, make decision without relying on the central cloud. That is called a cognition. So this cognition capability make the device as a self-adaptation, self-organization, self-healing, self-expression. So this will make this cognition property make the system without relying on the decision from the distant cloud. This is the one advantage, another advantage of fog edge computing. Next one is the agility. What is agility? So the agility to quickly, it means that ability to quickly adapt and respond to the changes happened. Okay, so FEC enhance the agility of the large scope IoT system deployment. So the system can able to, the FEC brings the opportunity to individual and small business to participate in providing FEC services using the common open software interfaces or open software development kits SDK. Next one is latency. So what is latency? Actually, normally every communication require ultra low latency. So the time sensitive functions, by applying FEC, we can do the time sensitive functions. We already discussed the smart devices. If you want to calculate the blood pressure, that time we won't store the data in the cloud. We are retrieve the immediately we want the result. That's why the device itself process that. So it will avoid the latency by providing the by supporting the locally handling the data. Next one is the efficiency. So FEC enhance the efficiency of the cloud-centric IoT system in terms of improving performance and reducing the unnecessary cost. So the process happens near the data source. The system can generate the result much faster. Then the system utilizes the gateway devices to perform the most of the tasks. It highly reduces the unnecessary cost of outgoing communication bandwidth. This is what we achieved the efficiency. So we can simply set these are the advantage of fog edge computing. How these advantages are achieved? How FEC achieves these advantages? Again, we say SCAN, that is storage, computing, acceleration, networking, control. So FEC node can able to provide these 5 services. So here I see the image. One FEC node is available. That FEC node will provide these 5 services to give that advantages of scale. First one, storage. The mechanism of storage in FEC corresponds to the temporary data storing and catching at the FEC nodes. So FEC nodes has the catching mechanism, so it can handle the local devices and the calculation. Next one is compute. Actually, FEC nodes provide a computing mechanism in 2 models, that is infrastructure or platform as a service, software as a service. What is infrastructure as a we know in a cloud architecture what is infrastructure, we already know. Then in a software as a service, we are providing 2 more services. First one is on demand, that is on demand processing. One more, another thing is context as a services, where the context as a services base provides a customized data provision method in which the FEC nodes can collect and process the data to generate meaningful information for their clients. So once again, I summarize that the FEC nodes provide a computing mechanism with 2 services, 2 models, that is infrastructure as a service and software as a service. So software as a service has 2 more things, on demand processing and context as a service. Context as a service means to provide a customized data provision method in which FEC nodes can collect and process the data to generate a meaningful information on their clients. Next one is acceleration. What is acceleration? A technique used to increase the speed and efficiency of the data transfer across a network. So 2 kinds of acceleration here FEC nodes used. First one is network acceleration. Second one is computing acceleration. Network acceleration and computing acceleration. Network acceleration means increase the network speed. How will it increase the network speed? FEC supports a network acceleration mechanism based on the network virtualization technology, which enable the FEC nodes operate in a multiple routing table in parallel and to realize the software defined network. So therefore, the clients of the FEC nodes can configure the customized routing path for their application in order to achieve the optimal network transmission speed. This is about network acceleration. Next one is computing acceleration. What is meant by computing acceleration? Means increase the computing speed of the, we can increase the computing speed. It increase the computing speed by GPU and FPGA. Network speed increased by software defined network. Okay, so computing speed increased by GPU, graphical processing unit, field programmable gate array. So to do a complex task, the GPU processor will be used. And for the field programmable gate array makes the units allow user to redeploy program codes on them in order to improve or update the functions on the host side. Okay, so the GPA handle the complex algorithm. FPGA make the user to redeploy their program codes. So it makes the computing very fast. It increase the computing speed. Next one is networking. So it provide two kinds of networking: vertical networking and horizontal networking. By two services were provided. What is vertical networking? Vertical networking means connecting sensor and machine with user in a production or production or location in the particular location. So that is called vertical networking. So it will include the TCP protocol, UDP protocols, HTTP protocol, and XMPP protocol. These are comes under the vertical networking. Next one is horizontal networking. What is horizontal networking? So here the machine to machine data communication across the entire value chain. So it includes the entire value chain. It includes 802.515 protocol and Z-Wave and Bluetooth. These things comes under the horizontal networking. And the last one is control. The control mechanism supported by FEC consists of four types, that is deployment, acquisition, mediation, security. What is deployment control? The deployment control allow the clients to perform customizable software program deployment dynamically. Next one is actuation control, represent the mechanism supported by the hardware specification and the connectivity between the FEC nodes and the connected devices. Third one, mediation control. This mediation control correspond to the capability of the FEC in terms of interaction with the external external entities owned by different parties. Last one is the security. The security control is the basic requirement of the FEC nodes. It allow the clients to control the authentication, authorization, identity, and the protocol protection of the virtualized run environment operated on the FEC nodes. These are the services provided by the FEC computing node. Okay, I refer these content from this textbook. Thank you, students. I hope you understand the introduction of the fog computing. So the fog is available next to the cloud computing. It rectifies the drawbacks of cloud center architecture. Okay. Thank you. Thank you.